Mass to volume stoichiometry. So this is exactly what it suggests. If you know the mass of one of the reactants or the products, you can work out the volume of one of the other products. So if you know the mass or the concentration and volume of the known, you can work out the number of moles of the known with C equals N on V, or of course if you know the mass, it's just N equals M on big M. Once you know the number of moles of the known, you use the mole ratio from your balanced equation to then work out the number of mole of the unknown, and using that you can work out mass, or you can work out concentration or volume of the unknown depending on the information that you have. Let's look at an example. What mass of zinc will be required to completely react with 50 ml of hydrochloric acid of concentration 2.00 molar. The reaction is given to you here, but this is an acid with a metal, so it makes a salt and hydrogen gas. So what information do we know? It's really important to read the question and to write down the information as it's told to you. So what mass of zinc? So we're asking here what the question mark of zinc is. So write down M equals question mark. Will react completely with 50 ml of hydrochloric acid of a concentration of 2.0 molar. So I'm going to put all of that information down. My volume of hydrochloric acid is 0.05 litres. Remember, volume has to be in litres. And my concentration is 2.00 molar. I'm trying to find out the mass of zinc, and I always know the molar mass of zinc, so I may as well write that in straight away too. That equals 65.4 grams per litre, or per mole. If you look at this straight away and you always set your work out like this, it's easy to get marks because you can see a V, you can see a C, you know you can work out N. It gives you somewhere to go. Once you've got N of hydrochloric acid, you can work out with mole ratio what N of zinc is. You've got M, so you can work out the mass. But we'll take you through that step by step. So, calculate the amount of mole of the known in mole. So we know the number of mole of hydrochloric acid will equal C times V, which was 2.00 times 0.0500. And we had that from the previous slide here. Just this information I'm transferring over now. Okay. So that equals 0.100 mole. The next step is to calculate the amount of the unknown in mole using the mole ratio. So 2 mole of hydrochloric acid, 2 mole of hydrochloric acid will react with 1 mole of zinc. And that's all I've written here. 2 mole of hydrochloric acid will react with 1 mole of zinc. So if I've got 0.100 mole of hydrochloric acid, it will react with the mole ratio, which is the unknown over the known, so 1 over 2 of zinc, which will equal 0.50 mole. Now, going back a step, think logically at this point here. If you set it out like this, you can always think logically. 2 mole of hydrochloric acid react 1 mole of zinc. That's half the amount, so it makes sense that we multiply this by half. This needs to be a smaller figure. If you get a bigger figure here, you can see that it's wrong and you've done something wrong, so go back and double check your answer. But always just check the size of these numbers. Hydrochloric acid must be bigger than zinc. Step 4. Calculate the required mass of the unknown. So, mass of zinc will equal the number of mole times the molar mass, which equals 0.05, which we just got from up here, times 65.4, which is the molar mass of zinc, which equals 3.27 grams. Okay, here's a question you can have a go at yourselves. So have a pause of this if you're feeling confident, and if not, just keep watching and I'll talk you through it. So there's a lot of writing here. When 2.0 molar hydrochloric acid is added to solid magnesium oxide, the basic oxide dissolves very rapidly and a large amount of heat is given out. The equation for the reaction is, and it's given you the reaction, so that's a good question, 2HCl plus MdO makes MgCl2 plus H2O. Part A of the question. If 50 ml of acid just dissolves the sample of the oxide, what mass of the oxide has reacted? Let's look at that part of the question first. So what I've done here is I've just rewritten the important parts of the question. When 2.0 molar hydrochloric acid is added to solid magnesium oxide, okay, the basic oxides dissolve very rapidly and a large amount of heat is given out. If 50 ml of acid just dissolves the sample of oxide, what mass of oxide has reacted? So let's look at what we know. Here's our chemical reaction. So let's start off by putting in our mole ratios up the top. I like to do that because it makes it nice and clear. So I've got a 2 to 1 to 1 to 1 ratio. Excellent. Let's look at the information that's given to us in the question now. So I've got 2 molar hydrochloric acid. So C equals 2.00 molar is added to solid magnesium oxide. That's here. 50 ml of acid. So V equals 50 ml, which equals 0.050 litres. Remember, volume has to be in litres. And it's asking us to find out what mass of the oxide has reacted. So I'm going to write under here M equals question mark, just to remind me what I'm looking for. Because I'm looking for M, I always know big M. So write that down now too. M equals 40.312 grams per mole. Going back to the hydrochloric acid here, we can clearly put in a V so we can work out. Excellent. Look at our mole ratio now. So we've got 2 hydrochloric acids will react with 1 MgO. We've got 0.1 mole of hydrochloric acid, so that's going to react with the mole ratio, which is the unknown divided by the known, so half times 0.1 mole of MgO. So the number of mole of magnesium oxide equals half times 0.1, which equals 0.05 mole. This is a good time, as I said before, to double check that it makes sense. 2 of those will react with 1 of those, so 0.1 of those will react with 0.05 of that. It's less, it's half. So that's correct. So we've done that bit correctly. We can now move on. What are we looking for again? We're looking for here the mass of magnesium oxide. So M of magnesium oxide will equal N times big M, which equals 0.05 times big M, which we've written up the top here. And that will equal 2.02 grams. 3 significant figures, because our question here has 3 significant figures throughout. Let's have a look at part B of the question. When 2.0 molar hydrochloric acid is added to solid, so it's the same question. Let's look at what they're asking though. What mass of magnesium chloride would be produced in the process? The first thing I'm going to do is write down the reaction again. And write down my mole ratios. I've got 2 to 1 to 1 to 1. And I'm looking for now the mass of magnesium chloride. M equals question mark. So let's write in big M straight away. Which equals 95.398 grams per mole. Now you've done the hard work in the previous question already. You've worked out that the number of mole of hydrochloric acid is 0.1 mole and the number of mole of magnesium oxide is 0.05 mole. You could use either of these to work it out, but I think it's much easier because this is a 1-to-1 ratio, so use your answer here. you can see straight away that 1 of MgO will make 1 of MgCl2. It's a 1-to-1 ratio, so you know that the number of mole of MgCl2 will equal 0.05 mole. And then all you have to do is work out the mass. So again, M of Cl2 equals N times big M, which equals 0.05 times 95.398, which is just the big M that I wrote down at the start, and that equals 4.77 grams. 3 significant figures, which is what my question had to start me off. What I'd like you to do now is have a go by yourselves at questions 5 and question 6 in the booklet and see how you go. And then I'm going to continue with just one more little question, which is on, or example, which is volume to volume stoich, which is on number 11 of your booklet. Volume to volume stoichiometry is exactly what it suggests. You know, the volume or the concentration, you can work out the volume or the concentration of something else. So concentration and volume of the known, you work out the number of moles of the known, you use the mole ratio to work out the number of moles of the unknown, and then you can work out the concentration of the volume of the unknown depending on the information that's been given to you. Let's look at an example. What must be the concentration of a sodium hydroxide solution if a 20 ml sample of the solution requires precisely 15.48 mils of sulfuric acid of concentration 0.06784 mole, that should be per litre, to completely react with it? Okay, so again, have a look at the information that you've got. What do you know from the question? We know that volume is 15.48 mil of sulfuric acid. We need to convert this to litres, so we get 0.01548 litres. We know the concentration is 0.06784 molar. Great. We're able now to work out the number of mole of this. What are we trying to find out? We know that V equals 0.02 litres, which is 20 mil here, converted to litres. What is our concentration? It's asking, what must the concentration of the sodium hydroxide solution be? So let's go through this step by step. Step 1, calculate the amount of the known in mole. So number of mole equals C times V, so it equals C, which is 0.6784, times V, which was 15.48 mil, which equals that many mole. Step 2, calculate the amount of the unknown in mole using the mole ratio. So we know that 1 mole of sulfuric acid will react with 2 moles of sodium hydroxide. 1 mole will react with 2 moles of sodium hydroxide. Therefore, 0.01050 mole will react with the mole ratio, which is 2 times the amount. And that makes sense. One of those will react with 2 times the amount of sodium hydroxide. So the number of mole of sodium hydroxide equals 0.021 mole. So calculate the required concentration of the unknown. Sorry, there's a bit of a typo in my notes there. So now that we know concentration equals N on V, we know what N is, we know what V is, so we can work out the concentration there. Okay, second question for you. If you're feeling confident, give it a go. I'm going to do the worked answer again, and that'll be the last one I do. So have a look once you've done that at the chapter questions here if you want to keep going. Otherwise, I'm just going to work through the example. Try and finish these booklet questions too if you can. Okay, so what volume of a solution of 0.20 mole of potassium hydroxide solution will exactly neutralise 20 ml of a solution of 0.300 molar sulfuric acid? Again, we need to read this and write down the information that we know. So So the first thing you need to do is write a balanced chemical reaction. So I've got potassium hydroxide, KOH, aqueous, plus H2SO4 aqueous will react to give a salt plus water. So it'll be potassium sulfate plus H2O, which is a liquid. Needs to be a balanced equation, so I've got 2 potassium here, so I'll need 2 potassium here, and I've got an extra hydrogen, so I'll need to put 2, 4 and a 2 there. So I've got a balanced equation now. My mole ratio 2 to 1 to 1 to 2. Okay, let's look at the information that's been given to me. What volume of a solution of 0.2 molar? So we're looking for the volume equals question mark, and it's got a concentration of 0.200 molar. So what volume of a solution of 0.2? Yep, will exactly neutralise 20 ml of a solution of 0.300 sulfuric acid. So V equals, remember it needs to be in litres, 0.02 litres. This is your biggest mistake that you're going to make, that you don't convert this into litres. And your concentration equals 0.300 molar. You can see a C and a V here, so straight away we know we can work out N equals C times V, which equals 0.3 times 0.02, which equals 0.006 mole. I've got a 2 to 1 ratio. 2 KOH will give me 1 H2SO4. Thus, to work out the unknown, I will need the mole ratio, which is the number of unknown over the known, times 0.006. Will make 0.006 H2SO4. Okay. So number of mole of KOH equals 0.012 mole. Does that make sense? If I've got one of those, I'll have double this, so I've got 0.006 and I've got 0.012, which is double. So that's correct. So I can move on. Now that I've got N, I've got C up here, so I can work out that V equals N on C. Just a reminder, because I've written up here, that's what I'm looking for, which equals 0.012 divided by 2 equals 0.0600 litres, or which equals 60.0 ml. Three significant figures, which is what the question has here, 3 significant figures and 3 significant figures. Okay, so on to these booklet questions, and you'll get the opportunity to work on these chapter questions in class.